YouTube, Jay Kilroy here with a brief video mostly centered around 3D printing. So if you're not interested in 3D printing, this may not be the video for you. Move on, wait for the next one. If you're here, you've probably watched the two videos from Randy Richard where Randy made a GoPro mount. Randy contacted me and said, "Hey, Jay, this might be something that you can make on a 3D printer. This looks like a likely candidate." So he sent me his CAD work, and I drew. I basically just converted his CAD work directly into SolidWorks without any changes whatsoever, and printed it out. And that's attempt number one right here. And well, anyway, let's just say, unbeknownst to me, because I'm pretty new to this 3D printing business, Randy had sent me hurtling up a rather steep learning curve as I attempted to print out the mount that he had made for his camera, and it didn't work real well. So when I've got a picture that I will post into the video that shows the GoPro in this unit here, and this unit being made, and the it was really wedged out. The camera barely fit. It was extremely tight. But let me show you a little detail here. So it was pretty much exact replica of Randy's mount. Same cutout here, same split bolt and nut method for holding the camera in. A recessed hole here for the Wi-Fi button, a recessed hole for the fire button, and a stud in the bottom for a 1/4x20 stud for a tripod mount. I did add the nifty Kilroy. You like that? That's pretty nice. So this was attempt for one. There are all sorts of issues with this. The camera would barely fit. And in Randy's code, Randy's drawing, this is 1/4-inch wall all around. I drew it as 1/4-inch wall, and then I had the printer print it. And the wall thickness varies from, say, 257 on the small side, all the way up to 266 on the thick side. So these are a lot thicker, and the tolerance, since it's a whole new way of thinking versus machining. It's completely different. In machining, we start with a piece of stock, and then we remove everything we need to make the part we want. Here, the machine's actually adding material out of nowhere. So that tolerance, if this piece here is going to be bigger than 250 exact, well, the tolerance is on both sides, so that if you go to 266, which is 16 thousandths large, you can basically just kind of assume you got an extra 8 thou over here, an extra 8 thou over here. And same on this side, except not. So what else did I learn? Radiuses. There you go, little radius in the corner, little radius in the corner here. Okay, inside radiuses specifically. Well, what do? Well, they print tight. So you specify an 1/8-inch radius, for instance, right? Well, you're working with a medium that's going down in 27 thousandths layers, right? So it steps to that. So as the machine prints and turns, there's a process by which the print head is slowing down, almost, you know, and then turning that turn and then going on this way. So the plastic is deposited. I mean, the G-code does control the extruder head in a variable speed manner. It can extrude more and less at different speeds. But as it turns this corner, more plastic is extruded around that radius. So the radii end up being tight. So this is another problem I found out. Another reason that this unit just would not work for several reasons. One, the camera just flat out almost wouldn't fit in there. The sides are too thick. Even with a generous chamfer, I increased the sizes of the chamfer that Randy put on his mount. I couldn't get my fat ass fingers down in there to actually press. This button was impossible to press. Yeah, I just flat couldn't do it. Had to, you know, get a screwdriver or something to press the buttons. So that wasn't going to work. So this was attempt number 1. Two, what I'm going to do, I'm going to move the camera around as we go, give you a better view as we go through attempts 2, 3, 4, and then the final rendition, which is attempt 5. So let me move the camera. Okay, here's attempt number 1 again. Walls are way too thick. You cannot access the buttons here. It's just too thick to get your fingers down in there. And the radii here in the corner print tight, so the camera barely fits. So taking Randy's CAD drawings, which were excellent, well executed drawings, no problems there at all, it's just the design doesn't translate over to this type of construction, not at those dimensions. So we're going to have to make changes. So attempt 2, I believe, was this. Oop, get me in the frame here. So this was attempt 2. All I did was I shrunk the walls here in the top. I shrunk the walls. I left everything else the same. And I printed. Now the camera fit in here a lot better, no problem. But there was one issue. When I shrunk the wall, I failed to account for the fact that the position of this hole would move relative to the side of the camera. So the button was half covered over here. So again, thought process, you got to think about what you're doing here. Other than that, nothing else was changed. At this time, though, I did notice one thing. The top of this cutout partially obscured the microphone section, the microphone entry on the camera. This is as far as a GoPro 4. Randy has a GoPro 4, I have a GoPro 4. So we're both working from the same unit. So this was partially obscured. So let's go on to attempt 3. So where's attempt? Which one is it? Ha! This is attempt 3. Now while I was doing attempt 3, you might notice I fixed the position of the hole and I moved this slot up 1/100 of an inch, and then I got rid of the split. You notice the split to that was here. Where's attempt 3, attempt 1? You'll notice the split is gone. There's the split. It's gone. I got to thinking about what I was doing, and I said, you know, why am I doing that? Why am I doing that split business anyway? Why don't I just put a clip in to hold the camera? I increased the dimensions here. I increased the size of the radii substantially from a 1/16 of an inch to 3/16 of an inch. And remember, they print tight. They print very tight. So I printed this one, it popped it out. I put the camera in it and hit this clip, and it immediately cracked. Crackle, you know, it's just a little glue right there, right, to reinforce that. But it immediately cracked, and I was like, well, that isn't going to work. Oh, and if you look down in here, you'll see a couple of tabs in the back. I had to lengthen the depth of the case 1/16 of an inch, and then I added a 1/16 of an inch thick tab, 2 of them, to the back to hold the camera in. When you slid the camera in, you slide the camera in from the front. I also added a recess here to allow the Wi-Fi button to pass smoothly into the case without being activated by the act of inserting it in the case, which was happening. So this was attempt 3. Okay, attempt 4. The button cracked, right? This thing cracked up here. So everything else left the same, except I then added a little recess. Literally, this is like a 20 thousandths recess in for the fire button to make it easy to get the fire button in. And then I added this rib. Let me see if I can show you that. I added this rib to the top of the button, top of the tab, to what I thought would be reinforce the tab. I want you to notice in this view here, the plastic is running, is deposited in lines in this direction, right? This is the layers, like a tree. And then I have this tab. This piece is basically 80 thousandths thick. This wall is basically 80 thousandths thick. And then I had a little extruded nose here with a little lip to hold the front of the camera that would hang down approximately a 1/16 of an inch below this tab. Anyway, I printed this one, waited an hour, printed it, put the camera in there, and this one promptly cracked too. So, attempt 5, and what I think is darn near close to a finished product. Voila. Of course, you're looking at this and you're going, hey, Kilroy, how's this any different? Let's look at the features here. We still have the recess over here for the fire button, the recess, for the Wi-Fi button, the recess for the fire button, the same cutout moved up a little bit, just about 1/100th of an inch to allow better sound access to the mic. But I changed the way the tab worked. The tab now doesn't break. Instead of making the tab this little short distance and this short kind of a little piece of plastic in tension, what I did is I turned the slot down this way. I got to say, I was rather proud of myself for thinking of this. Works great. Now the slot, I'm working with basically the grain, the lay of the material, not against it with this little short section here. And I changed nothing else about the tab, and it works really good. Overall, this is a handy mount, which is nice because I broke my frame mount. The mount I'm using right at the moment for my GoPro is a frame mount, and it broke. And I dare say that this one is more durable than the factory mount. Oh, I also added, so you get the original stud here in the bottom. Since I didn't have that nut to work with, that clamping slot, I moved the stud location here to the middle. We're going to put an insert here in a second. That's a 1/4 inch brass plastic. It's an insert designed for plastic. We're going to put one in here in just a second. But I also added one on the back, so that if you wanted to hold the unit like so, like off the end of a indicator holder, this would be handy. Why did I move it over to the side? Because it ran into each other. Because not only did I provide a recess. This is a 300 thousandths hole with a little shelf in it down here for the insert to sit against. I also added a little 257 hole in case you have a screw off of a tripod or some attachment that goes too far through and you didn't want to damage or pressure insert out. So I did the same thing over here. I have the same 300 thousandths hole and then a recess. So what we're going to do now is we're going to get the equipment and the inserts to add the insert into these two locations. Alrighty, we're back. This is my finished product, attempt number 5. And this is attempt number 4, and we're going to try out these inserts on attempt number 4. Here's the tool for doing it. This is just a little Weller soldering iron. It's a 40-watt iron. It has an insert in it that the little brass insert fits in, right? So you got to sit here until this gets good and hot. And then what we're going to do, we're going to do a practice run on version 4, which is destined for the trash bin of life. And then I have 2 more here to use on version 5. So let's wait for this to get good and hot. It's good and hot. Whoop. Isn't that a problem? Give it a second, let it cook there for just a sec. Let it melt nicely around the plastic. Give it a press down. There you go. And one of the other reasons I did this is because we're going to do a little torture test and see just how durable this is in a second after it gets a chance to cool nicely. But right now, we're going to press a couple of these bad boys into number 5, the actual going to be working model. All right, this ought to be plenty hot. I'm going to do the one on the back first. What I'm doing now is just pressing it down on that. Leave it a little proud, and then press it down on this bench top, this metal bench top, to press it in flush and square. There you go. Let's get a little view of that. Looks pretty good. Let's get the other one heating up. Alrighty, so it'll be hot enough. Let's give it a go. See if I can. Goes in pretty darn easy. Let it cook a second. Pretty nice. So that worked pretty good. Now let's take number 4 and let's do a little testing. see how this little insert actually holds up in this 3D printed plastic. All right. Put this in the vise. Let's get a wrench. All right. The implement of destruction. Got a 3/8 inch ratchet drive and a 7/16 deep socket. Let's go at it until we can't go no more. Let's see if I can get the camera in a little closer. Okay, I'd say we're at the bottom of the recess now. Now let's see what's happened so far. The insert's still flush with there, but the mount has failed dramatically as the bolt is pushed through. The bolt was able to push through all this plastic before failing the insert, but the insert is now, the bolt is now at the end of its threads, so the bolt is going to bottom out in the insert here in about 2 turns. So let's see what happens. Holy smokes. I gotta tell you, that baby is in there. The bolt is coming out. There is a plentitude of brass on the bolt. It is rather difficult to turn by hand. Matter of fact, that's not happening. Bolt in okay shape. There's a fair amount of brass off of the, out of the insert. And the threads of the insert definitely took some damage. Not that bad though. I'm pretty sure you could continue to use this if it wasn't all fugazied up here. But overall, the insert is still firmly seated in the part. It's going nowhere. Even after all that damage, I'm not able to pull it out. Hold on just a second. Let me get the bolt back in there. All right. let's do it to it. So it's still kicking. Let's try it like this. Let's see, where's that hammer? All right. We got the piece in here. Let's see. Well, I gotta say, folks, that's pretty damn impressive. The insert is still seated in the plastic, and the bolt is bent. That's a 1/4 by 20 stainless steel bolt, and it is bent quite nicely. The insert is still seated quite nicely, flush with the piece, even after all this abuse. So I'm going to say the test on this these little plastic inserts is in the affirmative. They are pretty damn durable. Alrighty, there we are. Here is my broken frame mount. These two little fingers here broke. 30-something bucks for this piece of junk. I'm gonna salvage some pieces off of it, however. This is going in the trash. The sacrificial bolt, you can see the angle that I bent that 1/4 inch stainless steel bolt over to without disrupting that mount. I think we gave this a pretty thorough torture test and can really bank on the fact that these little plastic inserts are pretty darn durable. But for this piece, it's going in the trash too. This was a fun project. It was a good learning experience. These little plastic extruding type printers, RepRap style printers, are fabulous for quick prototyping, inappropriate applications, and you know, again, this is number one, the one that was too big. I've got some pictures. I'm gonna put some pictures here of all that I've got of right now. I'm using the version 5. It's what's holding the camera as we speak, and it's working great. I've got excuse me, various pictures that I took, and some video from the phone that I took during the process, because I was using the GoPro as a fit-up tester. I only have one, and so I'll show you some of that stuff now. And I'd like to thank Randy Richard for bringing me in to participate in this project. It was a lot of fun. He has great design skills, super nice guy, just fabulous guy, great videos. Go check his channel out. Randy Richard, hunt him down. And we're gonna make some more of these. So I'm gonna make some more of these. I guess at the very least I owe Randy a mount or two for his trouble. So I'll be making some more of these, and not version 1, not version 2, and not version 3 or 4 either. Even though the 5th one was a charm. So you guys have a good one, and be back to you soon.